Right, snapshotting this idea and reminding you, you can plot your sine graph by using the table method on the calculator. If you do that, you're going to get the blue graph there. Remember that it is essentially a roller coaster where you go up first and then down. So if you can remember that, and then just do it on the left hand side as well, then you've got the right shape. Right, when you are changing the amplitude, it means that if that number that comes before the sine graph is bigger than 1, you're going to stretch the graph up and down, but it'll still take the same space on the x-axis. And if that number is smaller than 1, it is going to make the graph a little bit flatter, but also still take up the same space on the x-axis. When you have to calculate the amplitude, you can use the formula of half of the distance between the minimum and the maximum, or you can just ask yourself how far up did it go from the middle line and how far down, and that amount will be the amplitude, which is in the formula, which you may need to be finding. The period is how many degrees it takes to fit in one sine graph, and for our purposes now, it's always going to be 360 degrees. When we look at shifting the graphs up and down, it is because the Q value exists and it is not 0. So when the Q value is 1, so you are adding on plus 1, it means that you're taking your original blue sine graph and you're moving every single critical point up by 1, and so the whole thing shifts. If your Q value is -2, it means you've taken your blue graph and you've shifted it down, so every single critical point moves down by 2 values and you draw in your shape. I recommend that you always draw in your original graph in pencil. You can erase it afterwards if you like, but that you show the shadow graph for yourself so that you understand the transformations. Lastly, what happens if you have two transformations? So you have a shift with the amplitude and it is now a half, for example, and you've got to shift the graph up by 1. I recommend that you draw in your blue graph, your original sine graph, and then you change the amplitude first, because the amplitude is changed there and you've got to change that one, but the amplitude's easier to change first. So now we've got our new graph there, which is a bit flatter, and then we shifted each of those points up by 1 to get the graph that has now been shifted up by 1, but also the amplitude is changed. My orange graph here is what happens if the amplitude is negative, and that means that every single point of the blue graph is reflected in the x-axis. So the zeros stay the same, but where it was positive it's now negative, and where it was negative it's now positive. You're basically drawing a reflection of the blue graph on the same Cartesian plane.